Hello guys, today we'll be talking on regression analysis. I will explain the meaning of regression, the regression equation, and interpret the practical application of the parameters of those regression equations. Firstly, regression, when we talk about regression, what it does is to determine if there is any relationship that exists between variables, the dependent and independent variables, whereby one will be used to predict the other. For instance, as a student, one might decide to evaluate the performance of student, which could be that performance will be our y, the dependent variable, on the study hours, the number of hours the student spent reading. Now, considering those two variables, we have x, we have the study hour and the performance of students. With the study hour, you can predict the result or the performance of a student. Those two variables, those two variables, if you want to determine if relationship actually exists between those two variables, we use regression analysis. And what it does is just to check if the relationship exists, whether it is linear, non-linear, or whatever. So we simply say that the regression analysis is the study of the relationship between two variables, dependent and independent variable, whereby one, which is the independent variable, will be used or can be used to predict the dependent variable y. Now, a regression equation, this is the regression equation. Y is equals to beta naught plus beta 1 x1 plus beta 2 x2 plus beta n xn, depending on the number of independent variables considered. You can consider more than one independent variables. So for instance, there are still other factors that can affect student performance. So you can also have more than one independent variables. And when we have more than one independent variable, we call it multiple regression. Now, a regression equation can be linear, and also it can be non-linear. A regression equation can be linear when no parameters, these are the parameters that we have, beta naught, beta 1, beta 2. When these no parameters is multiplied by each other, or is being raised to any power. This is what I'm saying. If we have, for instance, if we have our y to be beta naught plus beta 1 squared x1 plus, when we have beta 1 beta 2 x2, when you have a parameter multiplying another parameters in the same regression equation, or is being raised to the power, that regression equation is not linear. It is linear when it is of this form. This is a linear regression equation. This is the linear regression equation. Sorry, I did not include the error term. This is the full regression equation. This is y equals to beta naught plus beta 1 x1 plus beta 2 x2. Okay, now let's just consider one dependent variable and one independent variable. For instance, I made mention of study hours and the student performance. So in study hour, we have our y to be what? The student academic performance, which is equals to beta naught plus beta 1 x plus ei. This is the regression equation to represent this, the data, the information I just made mention of now. So we have our y to be beta naught plus beta 1 x plus epsilon I, which is the error term. Now here is the meaning of these parameters. Now we have the intercept. This is beta naught. Now this intercept, for instance, if we model, if we obtain data on the student performance and the study hour, and we fit in the regression line, we have y to be 20 plus 2.5 x. Okay, assuming we have a data and we fit in the regression, we have a data on study hour and student performance, and we fit in the linear regression model of y on x, and we obtain the equation of this form. Now here is what this beta naught means. Now this beta naught, when x is equals to 0, you have 20. The beta naught is the expected value of y, the expected value of y when x is 0. Okay, so if the student don't study at all, he or she must have this particular 20. He or she will have this 20. Okay, so this 20, this intercept, is the expected value of the dependent variable, which is the performance, when x, which is the study hour, is 0. Okay, now the beta 1 here, which is 2.5, means for a unit change, for any unit change in x, the dependent variable is being increased by 2.5. Okay, for any unit change in x, which is the study hour, the student performance will be increased by 2.5. And now here is what the error term means. Now there are other factors that can affect the student performance, but not captured in this equation. Now this error accounts for all other factors which can directly or indirectly affect the dependent variable, but you are not considered in the experiment or in the analysis. So this error accounts for the effect of other factors that can affect the dependent variable, but not considered in the analysis. Okay, that is what the parameters of the regression equation and its practical application. Okay, thank you. In our next class, we will be solving real life problems where you can have, and you will see how to use this to obtain the values of this and how to interpret it. Okay, thank you.